Hello everyone, welcome to my YouTube channel. In this video, I am going to explain Class A transformer coupled power amplifier efficiency. So, analysis of Class A transformer coupled power amplifier. So, this is the basic circuit diagram of a transformer coupled Class A power amplifier. So, here instead of collector resistance, transformer is used as a load. So instead of RC here, transformer primary coil is connected. So how it affects the efficiency, that will explain in this video. Okay, so in series fed class A amplifier, load is collector resistance. Load is collector resistance. So this is the load collector resistance. Here VCC is applied. But in transformer coupled amplifier, instead of this instead of this one, instead of this resistance, here transformer primary coil is connected. Primary coil is connected. So VCC is applied to the transformer primary coil. So it will change the characteristics of load line. How? So load line, the basic load line is a line drawn between the saturation point and cutoff point. This is the saturation point and this is the cutoff point. This is C, this is S, saturation point. So the slope of DC load line is minus 1 by RC. Already explained in the previous video. Okay. So link is provided in the description. So now coming to the Class A transformer coupled amplifier, instead of RC, here coil is used. What is the basic property of coil? Coil has ability to oppose change in current, but here DC is applied plus VCC. So here there is no question of change in current in ideal condition. So change in current, there is no change in current. So theoretically, the resistance of this coil is 0. So obviously the slope of DC load line minus 1 by 0, that is equal to infinity. So the load line is seems to be like that. The load line is seems to be like that. Becomes the straight line. Slope is infinite means it becomes the straight line. Okay. So this will changes the efficiency of the entire power amplifier. So I will explain how it changes the how it improves the efficiency. So this is the actual load line, is the line drawn between the saturation point and cutoff point. Now instead of RC, a coil is connected. So what happened? So it's a slope of that line, load line becomes infinite. That means it becomes straight line. It becomes straight line. So what is load line? It is the line drawn between the saturation and cutoff point. So this point becomes VCC. VCC. Okay. Why? Because it is operating in the active region. It is operating in the active region. So definitely the swing is seems to be like that. The swing is seems to be like that. So obviously that V maximum is equal to 2 VCC. The V maximum is equal to 2 VCC and V minimum is equal to 0. At this active point, voltage is equal to VCC. Why? Because here VCC is connected to the coil of coil, primary coil of the transformer. So this primary coil is connected to the collector of the transistor. So coil has ability to oppose change in current, but here there is no change in current. So entire VCC appeared. So this is VCC. At active region at this point is VCC. So obviously the swing becomes the maximum value is 2 VCC. So but current Simply this is IC maximum, this is IC minimum. So this is equal to IC maximum, I maximum or I minimum. So I minimum is equal to 0, I maximum is equal to IC. So what is efficiency? Efficiency is equal to ratio of output power to the input power. So power amplifier is basically a power converter which converts DC input power into AC output power. So how to calculate that AC power? AC power. So AC power is equal to Vm by root 2 into Im by root 2. Im by root. So what is Vm? Vm is equal to V peak to peak value divided by 2. Im is equal to I peak to peak value divided by 2. Just observe these figures. So this is the V maximum. This is the V maximum. This is the V minimum. So peak to peak is equal to V maximum minus V minimum. But I want only Vm. This is the Vm portion only. This is the Vm. So peak to peak divided by 2 is the Vm. Similarly, I peak to peak divided by 2 is equal to Im. So therefore, PAC is equal to V peak to peak divided by 2 root 2 into I peak to peak divided by 2 root 2. Simply this Vm value is substituted in this equation, Im value is substituted in this value, this equation. So finally, V peak to peak into I peak to peak divided by H. What is peak to peak value? V maximum minus V minimum into I maximum minus I minimum divided by H. This is the AC power. Now substitute the V maximum and V minimum values. Similarly, I maximum and I minimum values. So just observe this figure. V maximum, this is the V maximum. So what is V maximum here? This is the V maximum 2 VCC. So V maximum is equal to 2 VCC. So in ideal condition, V minimum is equal to 0. Similarly, I maximum is equal to IC and I minimum is equal to 0. Okay. So here instead of I maximum, IC is substituted. Okay. Instead of V maximum, 2 VCC is substituted. So in this equation, instead of V maximum, here 2 VCC is substituted. 2 VCC minus 0 into I maximum IC minus 0 divided by H. So here 2 VCC into IC divided by H. So instead of IC, in this case, AC power, okay, instead of IC, PAC is equal to 2 into VCC into IC by H. Instead of IC, here IC, 2 ICQ is substituted. How it is possible? Just observe the graphical representation. This is the ICQ, ICQ. So ICQ, for example, ICQ is equal to 5 milliamperes are there. So the maximum current is equal to 10 milliamperes. Minimum current is equal to 0. 10 minus 0, peak to peak 10 milliamperes. That is equal to 2 into ICQ, 2 into 5 milliamperes. Okay, ICQ is nothing but the collector current at Q point, active region. So instead of IC here, 2 ICQ is substituted. So 2 ICQ is substituted. Finally, PAC is equal to 2 VCC into 2 ICQ into 2 VCC into 2 ICQ divided by H. That is equal to VCC into ICQ divided by 2. We know that PDC is the DC power. So DC voltage into DC current. So obviously DC current is nothing but ICQ. At active region, DC current is equal to ICQ. Therefore, efficiency is equal to PAC by PDC, that is equal to VCC into ICQ divided by 2 into VCC divided by, sorry, VCC into ICQ. Simply PAC is equal to VCC into ICQ by 2 divided by VCC into ICQ. That is what we call PDC. Final into 100. So VCC cancel, ICQ cancel. We'll get 50% efficiency. We'll get 50% efficiency. Thank you.